Hi, hello. Welcome to this series of tutorials with ANSYS for MECH3200. This tutorial, there's two purposes. One is for you to um, work on some problems of the online tutorial. And the second one purpose is to give you some guide or training to use ANSYS for your group project because you're going to need to do some modeling or simulation um, using ANSYS as well. So just starting with getting ANSYS. Firstly, ANSYS is available in all the computers in your UQ computer labs. So when you get onto those computers, they should already have ANSYS installed. And if you want to install ANSYS on your own computer, so you just Google ANSYS student version. So you go into their website, and there's a free version of ANSYS available for you to download. So it's ANSYS students. And then you should be able to download the latest version 2020 R2. So you can work on that. So when you install ANSYS, you'll find there is obviously an ANSYS folder in your manual, but the thing you're really working on is we called Workbench. So it's here. So Workbench will give you to the platform. So I've already opened here. So in this Workbench, you get a series of functions you can use or models you can do with ANSYS. So the first, because there are a few videos showing you how to build a model and do analysis. But because those videos are made a couple years ago, so one thing is ANSYS has introduced a new software package to define the geometry. So all the other videos I've made were using the old software to define geometry. So basically in here, when you have a geometry, you right click. Remember in the other tutorial, I just say double click here, but actually when you right click, there is an option of so-called space claim and design modeler. So there's an option of two geometry designing software. And by default, you'll go into the space claim. So basically, if you double click this, you'll go into space claim. And if you want to use the design model, you have to right click and select this one manually. That's a way, if you want to follow the rest of the video, when I say double click, you really have to right click and go into the design modeler to follow those instructions. But I think the new software is also very useful. So in this video, I'll just quickly show you how to use the new space climber. So just double click, and then we'll go into the space climb. While it's loading, we just have a look at the problem. Sorry, the problem is the weak 8 problem. Okay, so we're looking at a this like door frame structure. It's a beam model. All right, so now we are in space climber. So first thing we want to do is we want to draw the beams or draw the lines and later on define the lines as beams. So now we see this plane, and we're drawing at its XZ plane. We don't want to draw at XZ plane. We really want to draw at XY plane. So what we can do is we just change, move the plane. So we just want to probably move this down by 90 degree. Okay, so now we are at XY plane. So then we can draw the lines. So in the first one, we're starting from 0. And this one, it needs to be, I'll just use some standard value for the geometry. So this one needs to be 8 meters. And the length, I'll just say 7 meters. And then the next section is 5 meters. Then we come down another 8 meters down. Okay, so that's the frame we have now, corresponding to this. Remember, you have to define 2 separate beings here, because later on we're going to look at each different beings. So now we have those lines. Then we need to define the profile of the beings. So in the profile, the prepare profile, you want to add the I being. So that's the I being profile. So now we have created a beam profile. It's a standard beam profile, but we can edit. So now this is the I being we have. So we can define those dimensions, like width 1. So you have to define it according to the tutorial, but here we just put some different values, so you see this section becomes shorter, and W3, for example, we put 150, and so become shorter as well. So yeah, you can play with it and put your bin section in, and we'll close that. Then we want to create beings, so it just converts those lines into beings. So just create beings. Then we just click those lines one by one. Note they become slightly fatter. Yeah, so now they are beings. To show the being section, so here there's a display. Currently we just see the where, but now we want to really see the solid beings. If we click that, so you see the actual, if you click that, you just the actual beings. That's your I-shaped beings. Just one more thing. In this particular problem, we do want the beings, the top beings and the side beings being in a different profile. So we're going to need to create a new profile for the other type of beings. So again, just go into profile and I being. So you see by default it being called I and I2. You can obviously just rename them. For example, just click here, rename. So this top beam, and this can be side beam. All right. So then for the second beam, you can just do the same thing. Edit the dimensions. Just put those dimensions in. I won't repeat that. So then you just want to assign those profiles to your beings. Sorry, they're here. So now, for example, this is a top being. So in here you can choose the profile being top beam, it's okay. So this one is actually a side beam, so just say side beam. Just by the way, when you choose the profiles, you get all those parameters. You need to use the I-XX and I-YYs of your beams, so you can use them in your calculation and the cross-sectional area. So it's been top beam, so this one is top beam, okay, and this one is side beam. So just say side beam. Okay, so now they are changed to the right side. Okay, another thing we want to do, remember, we need to define the orientation of the beam. So we want to rotate those beams. So the way we can do is, now see these are the 4 beams we have just defined. And click one beam, we can change the orientation. So we can put them 90, for example. And these beams, they don't, do they need? They do need change orientation as well. So 90 and 90 and 90. Okay. So now we get the orientation of those beams correct. And then currently they are 4 separate beams. Basically, they are not connected. So we want to select all of them and right click. So we want to move to new components. So that way you can kind of join those beams. And in that components, when you have that component, you have to define the shared topology. So we want to share the topology. That means the beams are connected together. Okay, so the last step is to define the material. It can be done in the modeler, but it can also define here. So in the material, you just select one beam, you get a material, and you can select the material you want. So in this case, we wanna steel. This one is actually stainless steel. Let me have a look. So the density is 7,800 elastic. Yeah, it's pretty much the same. So all we concern is density and elastic modulus in this case. So we don't worry too much about other like tensile strengths. Material, okay. All right, so we made all those beams as stainless steel. And that's pretty much, so we have the geometry design in this case. So afterwards, you can go ahead, just follow the other videos to model those beams. And that will be the same to other videos. So the next part is because we have another problem about the shell elements. So the shell model is similar. We'll just put in another model analysis and double click, go into this space clemmer. Okay, and here the shell element is quite easy. You just draw the shape. I'll just quickly draw 5 meter. Sorry, in the wrong direction, is it? So from this, and then 90 degree, 5 meter. um, okay, this one going out by 7 meter. All right, then we connect them. All right, so we have created this plane. Then we just need to finish. So we have created this area. So it's called a surface. So by default, this will become a plane or a plate. So we can define the thickness of the surface. So let's say 0.2 meters, for example. So yeah, that's pretty much all. So we have created a plane with a thickness. So yeah, that's all for the space climber. So there are quite a lot of tutorials you can get online if you want to create more complex geometry. So you can search them if you want to use that for your group project. So that's all for this tutorial, and enjoy the rest of the videos. Thank you. Bye.